Hello and welcome to our webinar on automatic infrastructure monitoring. My name is Ross Beard and I'll be facilitating today's webinar. We're really excited to share some of our insights and knowledge to help you improve the way that you automatically monitor your infrastructure. Here is our agenda for today. I will speak briefly about Shadowsoft, Icinga, and our relationship. Jeff and Brandon will talk through our four-step methodology for automatic infrastructure monitoring. They'll walk us through a demo, and we will have some time for a Q&A at the end. Now, I encourage you to use the chat pane on the side to ask questions throughout the presentation, but we will be addressing them all at the end. About Shadowsoft, we are a consulting firm that guides organizations to business agility through open solutions. What that means is we're a team of strategists and engineers with rich open source and integration experience, ready to act as your trusted advisor. I'm really excited for today's webinar because we're speaking about two of our core capabilities, which is infrastructure monitoring and automation. And we'll be talking about the technologies that we really have a lot of experience and certifications around. So from the monitoring side, Icinga, and from the automation side, Ansible, Chef, Puppet, and Terraform. Speaking of Icinga, we've been partners with them since 2016. In fact, we are the support provider for North America. What that means is we handle all of level 1 and level 2 support and work quite closely with the Icinga team in Germany for any level 3 support. We're quite involved in the roadmap with respect to the product. So we work a lot with our customers to understand their needs and pass that feedback directly to the product team over in Germany. And we run events and training here in the US. On May 23rd in Atlanta, we are hosting Infrastructure Monitoring Day. And the Icinga product team is going to be flying over here for the event and running a couple of talks and sessions. We'll be following up with some details regarding that after the webinar. And lastly, we do training once or twice a year. We'll be also following up with some information regarding the training. Okay, the speakers for today, I want to introduce Jeff Williams, who heads up our monitoring team here at Shadowsoft. He is responsible for strategy and product development.
Hello, everyone.
And Brandon Engelberth, who is a senior Icinga engineer, who is responsible for leading client engagements and executing some of the consulting services that we offer.
Good afternoon, everybody.
On that note, I'm going to hand it over to the guys, and they'll take it away.
Okay, everybody, so this is Jeff. I'm going to talk through the slides, and then Brandon's going to give us some practical examples that he's seen in the field, talking through this methodology that we use when we're implementing a system or we're helping to analyze and refine a system. So we use a four-step methodology when we come in to help you with a monitoring engagement. First, we analyze the system that you have. We analyze the platform that you have already, how it's architected, how all the pieces are connected. We analyze what roles each of your machines are in and each of your devices so that we can determine commonalities and differences between those roles. All of those things will help when it comes to actually building out the second part, the monitoring system. We can build the entire infrastructure, the masters, databases, satellites, whatever's needed. And we would always try to use automated method to do that if possible. The third phase is to automate that, and we'll go through that in some detail. We want to automate, especially connecting the clients to the monitoring infrastructure. But also there are other additional higher levels of automation that we can implement depending on how deeply we've analyzed the system and determined the roles that need to be monitored. And finally, we extend the system to add additional features. Then we let it run for a while, and if what we recommend is taking an iterative approach to your monitoring so that we can go through all this again and say, okay, now that you've had it for a while, what do you want to change about it? And we would start with the analyze, build, automate, and extend cycle again. So in the analysis phase, we're going to review your existing infrastructure and architecture. So specifically, we want to look at every machine that you want to monitor, which should really be every machine. We want to take those machines and classify them. So a typical classification would be, we have Windows machines, we have Linux machines, we have Unix machines. We have Linux machines that are web servers, Linux machines that are database servers, Linux machines that are app servers. So we start classifying them down into roles. We can have an inherited infrastructure of roles where we can say, well, it's a Linux machine and it's a web server, so we want to monitor it this way. The second part of the analysis that we would want to do is we would want to look at the network hierarchy, determine where the firewalls are, where the security boundaries are, because this will have a lot to do with how we will design the monitoring infrastructure. And then we want to identify patterns based on similar roles. Once we've analyzed the roles that these machines fulfill, we want to determine what the templates that we're going to use to monitor those are. And we will build out we will design a probable template hierarchy saying how we're going to monitor each of those roles. So Brandon, when you've done this at customer sites, what are some of the issues that you've?
Yeah, Jeff, so typically it comes to mind is Platform Creator that we've worked with in the past. They also offer this as SaaS, where they wanted to get going with monitoring with Icinga, but they felt overwhelmed by the prospect of it. So we went in to do an analyze engagement, helped talk them through lots of whiteboard exercises, allowing us to break down and discuss what their actual machine roles were. They initially thought they had many, many machine roles, but as you talk through it, it does become simpler than may have anticipated. So helping to design that out and then working through the overall role hierarchy helped take away that anxiety of getting started in the analysis.
All right, the second phase then is to build out the infrastructure. So we want to build the core monitoring infrastructure based on the network topology. And we're going to show a diagram a little later where we talk about a typical topology. But typically what we have is we have masters that are doing the core tracking of all the monitoring and scheduling of all the monitoring. But we also have satellites that we can put out in your network that may, if we do it right, you may not even need to punch any new firewall holes to be able to get that monitoring data, even from a secure zone, to those masters. Of course, it depends on whatever security rules you guys, your company would want you to follow. But we would certainly look at your network topology, figuring out exactly where to place each of the systems so that we would be able to monitor everything for you. Second part of that would be to build out role-based templates with the basic checks. So what we would want to do is we would want to make sure that all of your machines are being monitored, machines and devices, for the most obvious things. So I always use disk as an example. It's like, I want to know for every system that's in my footprint, I want to know if it's got enough disk space. And some machines are going to run a little more hot on disk space naturally because of the kind of applications they're running, and some of them are going to run a little more cool. So that's where the role-based templates, some are going to have web servers, some are going to have DNS servers, some are going to have who knows what, FTP servers maybe. So we build out the role-based templates based on the analysis that we had done in the first phase, using the basic checks that come with Icinga. At this stage, we want to resist the temptation to implement custom checks. Every customer I've ever spoken with, they have a lot of custom checks they want to implement. It's like, we have this system that has a lot of custom features that we need to monitor. And so we want to make sure that we resist that at this point, because we mostly want to get the core monitoring working, and then we, in a later phase, we'll implement these custom checks. And that's the last point, is get something working. We're trying to get the guts of the system up and running and make sure that we're connected to all our infrastructure systems, and that the basic stuff is working. So Brandon, where have you seen people gone astray, customers go astray with this phase of the build out?
Some common issues is building out the infrastructure that we see at, all customer sites is going to be the firewall restrictions between different network segments getting in the way, not having adequate planning around that, and enough engagement with networking and security teams. And also what we see many times is a tendency to want to do the big and flashy custom features immediately in the project, and kind of getting sidetracked and distracted away from the basic monitoring. What oftentimes we see with the satellites, not only are they going to, as Jeff described, spread the load, but they'll segregate as well. So almost all our customers end up using satellites to segregate out their networks, what information is then contained on each satellite server. So if it would be inappropriate for information about machines on one network segment to be known in another, satellites can help solve that problem.
Okay, so on this diagram, we're talking about the infrastructure that we would build out to be able to do your core monitoring. So the main part of the infrastructure here are these two master nodes. This diagram shows a highly available system. So we would have two master nodes and a database in between them. So the master nodes know the monitoring configuration and distribute the pieces of that configuration out to the satellites that are going to do the actual monitoring. The database in between is for recording the monitoring results. And then the web machine is for displaying the monitoring results that have been put into that database. The satellites in this configuration are doing the actual monitoring, and that's why you see they're connected to the clients. So the satellites only know the piece of the monitoring configuration that's important for them to be able to carry out their jobs. And the clients are connected to each satellite. So if one satellite were to go down or something were to happen to their networking that would interrupt the connection to the one satellite, the other satellite can pick up and continue on. So that's how high availability works in Icinga. Well, also you should notice that each satellite is connected to each master. So you've got those redundant connections there as well. So Brandon, what are some of the common problems you've seen when people are actually implementing, this configuration in the field?
Yeah, common problems, to reiterate what we've talked about, is firewalls are step in the game, especially if there's different zoning or networking happening between the satellites and masters, or even satellites and clients.
Yeah, that's definitely a common problem. Okay, now we come to the automation part of it. So when we're talking about automation, there's really 3 levels of automation that we consider in an engagement. The simplest level of automation is installation, and so we're mostly looking for to install the client software on your client machines at that level. And the second level would be to connect those clients to the infrastructure, which you can do by hand. You can do the install by hand. You can do the connect by hand. It's just harder. And it's going to take a lot more time, especially if you have a couple thousand clients that need monitoring. And then finally, the configuration. If we choose in the engagement to have the automation system write your configuration, your monitoring configuration, we can also automate that based on the templates and the roles that the machines are playing. So for level 1, client installation, we need to establish the automation framework. This can be done with any kind of automation software, but we in general would be using Puppet, Chef, or Ansible. We've done a lot of work with Ansible in our group and have been very successful with that, especially installing clients and also installing the infrastructure itself. What we're doing to the clients is we're just simply going to install the base Icinga 2 client software. This is a great way to be able to monitor things that generally can only be monitored on the machine itself, like CPU load or disk space. And then maybe later in this implementation, we would use this automation system to also install custom check plugins. It's part of the normal Icinga client installation to install the standard plugins, but custom check plugins, if you've already got the automation established, installing additional custom check plugins later on is going to be much easier. What kind of problems have you seen customers run into with client installation?
So some stuff that we see with client installations oftentimes is having access to those in machines, the actual client machines, to do the testing, do the installation. Oftentimes organizations can be siloed in a manner where app team owners or infrastructure teams own their equipment and their machines. The monitoring teams may be separate. So having adequate access to those client machines is critical. We can see some resistance from app owners to having additional agents or check plugins installed on machines, but it's important to reiterate to them that it's critical to monitor their infrastructure and their applications sitting on top of it. And again, to reiterate what Jeff was mentioning, is if there are custom checks developed, this is the stage where you want to be deploying them, because they're probably not going to be coming from packaging systems, and keeping them all in sync on all your machines is much easier using a tool like Ansible.
And one of the reasons why you want to use the Icinga 2 agent running on your clients instead of using other methods that people may be familiar with, you can execute check plugins on the individual clients using SSH, but the overhead in connecting via SSH and starting up another shell just to be able to do that is significant compared to using the Icinga 2 agent, which is very, very lightweight. So that's really the reason why we would want, and also the connection between the satellite and the client is fully encrypted, so there's no data that's going to be exposed on your network while the data is in transition. Okay, and then level 2 of automation, we're going to talk about connecting clients to your monitoring infrastructure. So in level 1, we installed the Icinga 2 monitoring software on your client. We've installed the check plugins that it needs. But now what we're going to do is we're going to actually connect that to the monitoring infrastructure. So what we want to do here is we want to make sure that all the infrastructure is already set up and working correctly. We're going to use the automation framework that we talked about in level 1. We need to know exactly where each client is going to connect in that monitoring hierarchy. So if you think back to that diagram, there were 2 different monitoring regions. It's important sometimes to, and this is based on the network topology analysis that we did in the analyze phase, it's important to connect to the satellites that are in your same monitoring region as opposed to trying to cross regions where you may run into firewall complications and things like that. So what we're doing in this phase of the automation is we're getting the SSL certificate set up, we're having those encrypted connections working for us, and it's a significant amount of work to do by hand. It's also a significant amount of work to automate, but it's worth it because you're going to save so much time in the long run. Once you get the automation working for the first 1, 2, 3 machines, then the rest of them are just going to fall out of that naturally. So Brandon, what do you see? What have you seen that where customers have run into trouble specifically in this area?
Yeah, when you get to the connecting the clients up to the Icinga infrastructure stage, many organizations have automation tools that may predate more modern tooling like Ansible or Chef. And these more limited tools may make it very easy to install software, but when it comes to configuring it, getting your TLS certificates signed correctly, it can involve a lot of custom scripting, whether it's creating Python code or batch scripts for Windows. This step can definitely take some more time if there aren't more modern automation tools in place. But that doesn't negate that it's not worth it, because prospect of setting it up for potentially thousands and thousands of machines by hand, you absolutely will gain the benefit of doing some custom code up front. Also, we see oftentimes many different tools available in an organization, which cause problems with focusing in on one tool that's going to solve this specific problem.
Okay, and then the highest level of automation would be to have your automation system write the monitoring definitions. So if what we've done is we've thoroughly analyzed the roles that these machines are fulfilling, we can take that knowledge, build out a template hierarchy, and then have those templates have the automation software write monitoring definitions using those templates, so that instead of having to write a monitoring configuration for each machine, the automation can write those configurations. So this is the most sophisticated implementation of automation that we've seen. You want to make sure before you attempt this that level 1 and level 2 are addressed thoroughly and working before you attempt to do this. This is going to have the greatest payoff in terms of rapid deployment and manageability. So the deployment, I think we can all see how if the monitoring system is writing your monitoring definitions, the deployment is going to be speedier. The manageability is not to be neglected. When you add systems or change their configuration or their roles, you want to make sure that your automation system can push those new monitoring configurations out, so that you don't have to have someone go in and manually monitor alter all those monitoring definitions. The other thing to keep in mind with the automation at this level is that there are many different configuration entry points. You can define your monitoring configurations in config files. You can use the Director API, or you can use inventory databases. And we've seen we've been able to implement with customers all of those approaches in an automated fashion. But Brandon, what are some of the problems you've seen customers run into in this phase?
When tackling this phase of the automate this level 3 writing your monitoring definitions, customers get hung up with not having a quality inventory. Generally at this scale, organizations don't. And just using the inventories that you do have, even if it's at such a low level as this is a Windows machine or this is a Windows machine, can get you all those base level monitoring, get you 80% there, which is going to be a great boon, as opposed to potentially nothing being monitored. So being able to just move forward with the information you have is critical. And then, as Jeff has alluded to many times, iterating on it, you can get those extra monitoring and more specific services monitored as time goes on.
Yeah, I think it's a great point, Brandon, is that so you can say, oh, on this particular type of app server, we aren't monitoring that it's listening on this port, instead of having to go in and change that monitoring definition on, let's say, 8 systems. You just change it in your automation or in your templates and have that automatically deployed. Okay, and then the fourth phase is to extend. And this is where we would advocate that we implement custom checks. So all of those custom checks that everyone wants, it's like, well, we need to make sure that this file is in this location and it says this. Whatever your custom checks are, you want to resist the temptation to do that in the early phases and hold off until you've got the core of everything working and monitored and all of your infrastructure up and running, and then start deploying your custom checks. So application or product specific checks that standard check plugins do not address. Everyone's got these, but you want to make sure that you have everything else working first. And then you want to integrate additional tools. So performance data, Icinga does not track your performance data, like how long did it take to ping your web server. It doesn't not keep track of that on a historical basis. If you want to keep track of that, you need to use a performance time series database like a InnoDB or an InfluxDB, and then tie in Grafana or some other analysis tool to display those things. You want to build out in this phase additional dashboards, custom displays, and graphs, specific teams. And you can implement a number of different dashboarding tools at this phase, but those are all extensions. Additionally, you want to make sure that you build out all your notifications, and this may be, instead of the stock notifications from Icinga are simply email, and so you may want it to go to a Slack channel, you may want it to go into a ticketing system or an event correlation platform, and this is the time to get all of those pieces working. So Brandon, where have you seen people run afoul in this phase?
This is the very exciting phase that everybody. So that's what I see is trying to jump on this immediately when a project starts. Too early, trying to throw custom checks in before your Icinga infrastructure is even healthy or set up correctly, which can be a setback and a distraction. This is also a great opportunity to plan your notification architecture. Icinga has very rich notifications around who's getting notified, under what circumstances, thresholds, how's it getting escalated, what's the repeat pattern for notifications that have not been acknowledged. So we'll oftentimes see customers kind of start to feel a little burnout at this phase and not really analyze their notifications and just like do a copy and paste from their previous system. But this is really a great opportunity to try to reduce the noise for your operations team.
Okay, so just to reiterate, the four-step methodology is to analyze the system, the network, the roles that your machines are playing, build out the core of your monitoring system, automate at whatever level makes sense for your organization, and then to add the extensions at the end. But what you want to do then is you want to iterate on this process. You want to go back after, let that run for a little while, go back and look at your system and say, where are we not getting everything out of the system that we want? And so you begin that analysis process again, look at your roles, see how you could improve the monitoring of them. Look at the network topology. Did you really get all of your devices and all of your machines monitored? Build out additional infrastructure if needed, but also automate. Don't resist the temptation to not extend your automation. You want to make sure that that's a tool that you can use for as long as you have those machines, and then add in whatever additional extensions you want. So monitoring is an ongoing process that you need to continue to watch for as long as you run your systems. Okay, so now we have our demo. We're going to have two phases of this demo. The first one is an automation demo. We have a Terraform and Ansible job that will spin up a lab environment from scratch in the cloud. It contains a master, a web server, and a database server. The Terraform will create the machines. We'll have a slide in a second that shows this. We'll create the machines, and the Ansible will configure the machines. And then the second part of the demo, we have a system that we've already put together for you, because it takes a little while for the Terraform and Ansible to run. I think we said it was 13 minutes, right? Yep. So instead of watching a bunch of Terraform run, we're going to jump to an established system demo. We're going to show what Icinga looks like with the host services, host groups, etc. We're going to show a couple of custom dashboards and a little bit of the graphing that you can get from Grafana. So the automation demo, the Terraform is going to be used to create the infrastructure in AWS. So what we're doing is we're creating DNS names for the machines in Route 53. We're creating the virtual machines in the first place. We're putting them in the DNS. We're creating an Ansible SSH key so that Ansible can do the configuration of the machines. We're also putting in administrator SSH keys, configuring the security groups, and we're configuring instances for the masters, satellites, databases, and web. And then we create an Ansible inventory file that contains the IP addresses and the host names, along with the roles that those machines that we've just built out with the Terraform are going to fulfill. Then we pass control off to Ansible, and Ansible is going to install the Icinga monitoring packages. It's going to create the initial Icinga networking configuration to get the monitoring infrastructure up and running. It's going to install the database schema and the database authentication, and it's going to configure the Icinga web packages and additional Icinga web modules, and it's going to configure the Icinga connections between the systems. And I believe that the demo configures, it connects some client systems to it.
This is our architecture that we've seen already previously, which is closely resembles what we'll see in the demo here. So I'm going to go ahead and share my screen now, and we'll kick off this little demo. Okay, so to get started, we have a Terraform script that's going to spin up our infrastructure in AWS. So that's going to make our EC2 instances, set up correct networking, set up correct firewalls. As you can see, we're setting a couple variable configurations here to make sure it gets created how I want this lab. So it's going to analyze and figure out what infrastructure it needs to build within AWS. So it's going to build 25 different pieces of infrastructure for us. And we'll just kick it off. Going to analyze and start creating those instances and the firewall rules. And once everything's up and running, it's going to jump into our Ansible playbook and actually install and configure Icinga and all required dependencies. So if we jump over to the oven to the left here, see the completed cake, system's done. So Terraform's letting us know our various IP addresses and the DNS record for this demonstration system. So I'll go ahead and open up the demo system, and within my web browser here. And for the purposes of this demonstration, I turned off one of the satellite systems so we can see some problems with the within Icinga. So when you first log into Icinga Web 2, you're presented with the current incidents window. And there's 3 panes on here by default. You're going to have your service problems listed by priority in the left pane. These are service checks that are currently having issues. And directly next to it, it's going to be recently recovered services. These are services that recently were having issues and returning a non-OK state. And then on the last pane, the real critical is our host problems. So this is a host that our host check is represented as down. This host is likely not operational, secondary satellite. Within the Icinga Web 2 interface, there is the possibility to organize your hosts into various host groups. Oftentimes we see organizations organizing their hosts into geographic regions, data centers, network segments, the application teams that own that infrastructure. It's a great way to organize and then drill down directly into various host groups. You see we have our Icinga infrastructure split up into all machines, just masters, just satellites, Linux servers, and 0 Windows servers. And you also get a very traditional sort of style knock view here with nice graph showing you a summary of all host problems, all service problems. So you can get a very quick sort of managerial overview of how your infrastructure is operating. Once a problem's been identified, there are some tools to help troubleshoot. One good one is the service grid within Icinga. So our satellite 1 is down, and we can see this, that there's all sorts of problems with all its service checks. And we can see a related service problem. This cluster check for the other Icinga infrastructure are all also in a not OK state. From here, I can jump and I can actually look at this problem host and try to determine what is going on. From this problem host, I can set any host, whether it's down or not, into a downtime If it's in an okay state, maybe I have patching coming up, set it into a downtime, and then alerts will no longer go out for that host. It will continue to get checked, and the results will be displayed within the Icinga interface, but it's not going to send out notifications. There's the concept of acknowledgments within here, and that's going to be for a system, for a host or service in a problem state. You can acknowledge the problem, and what that will do is it will put a mark next to the host or service, and it's also going to, again, suppress those notifications. So you can acknowledge, here's my ticket number, or maybe a more sophisticated setup, your ticketing system is auto-acknowledging back into Icinga, something along those lines. So we'll look at a host that is not down right now and look at some of the graphing. So you can see performance data is getting streamed. We have the system set up to stream to InfluxDB, and then we're representing it with graphs with Grafana back within the Icinga Web2 interface. And this module, this Grafana module, is clickable. So I can click on this graph, and it's going to launch me into Grafana, where I can slice and dice the data to however I need. And with the data streaming into another system and displaying it graphically within Grafana, you have access to additional graphs and troubleshooting. This is one we like a lot for troubleshooting the Icinga service itself. It's pulling all these metrics about various queues within Icinga that you can correlate to issues within Icinga's running. The last thing that I want to highlight within the Icinga system is the history. So Icinga maintains a IDO database, and within that is a history of the states of the service checks. So if I'm sitting here looking at the ping service here, I can look at the history and I can see that it was okay at one point in time. Then it started failing in a soft state until it hit that critical state. And I have my timestamps right here for debugging.
Alrighty, thanks Brandon and Jeff. Really appreciate you both talking us through the methodology and specifically some of the challenges that our customers face. The reason why we host these webinars is that we want to highlight these challenges to help you perhaps not face the same challenges yourself, or have a few new ideas on how to overcome them yourself. Now it's time for Q&A. If you have any questions for Jeff and Brandon now, please enter them into the chat pane and we'll do our best to answer them. While we wait on a few questions, I know one that always comes up is the recording. Yes, we will make it available. My colleague Jared Gay will be sending out an email after this event and we'll include the link. Okay, we have a question. How does Icinga tie into AWS versus Cloud Vision monitoring?
Okay, well, obviously, Cloud Vision monitoring has a little bit of an advantage in that they get to tie directly into AWS features to be able to do the monitoring. I would say one thing that's a difference is it's probably, you're not relying on just AWS to do your monitoring. There's a lot broader range of check plugins that you can employ on a system that's using Icinga, because there's a library that's been developed over literally a couple of decades of different check plugins you may be able to employ to monitor application processes that are running on those systems, as opposed to the check, or just the checks that they give you in CloudFormation.
Okay. Thanks, Andrew. We have a question from Jerry. What were those infrastructure checks?
The infrastructure checks, for like the Icinga service, I think is probably what we're talking about. So there are a number of different statistics that Icinga keeps track of on its links between the masters and the satellites and the clients. And these can be very important for monitoring if there's a bottleneck or if your systems are a little bit overloaded. We have found that the satellites and the masters are pretty hard to overload, but in that in general, you can monitor somewhere, a single satellite pair can easily monitor 1,000 systems, depending on how many service checks you've got going. But and that masters can monitor, a similar number, but it can collate the results from multiple thousands of systems with very little trouble. Once you start getting into those high numbers, though, you do need to watch, just like with any system, you do need to start watching to make sure that the system's not backing up, both from an operating system perspective, like watching your top display, but also from an Icinga perspective. And that's where those Icinga 2 internal statistics can be very helpful.
Okay, thanks, Jeff. Any final questions? Oh, we have one more from William. How can I isolate stats and dashboards for multiple sites?
So there's a couple different ways to solve that problem. Role-based access control can build out for users in the Icinga Web 2 interface. They can only see specific objects. And then additionally, you can have Icinga, you have broken it up by satellite region. You can have additional Icinga Web 2 interfaces that are just associated with specific satellite checkers.
Well, and yet another way to do it is you can have host groups that separate your hosts out either by role or by physical location or any other criteria that you may be interested in. And so even if you've got like Icinga administrators, but they want to focus in on a specific group of hosts, host groups are a great way to implement that. So there's multiple different mechanisms for approaching that.
Okay. So next step, was this interesting? We would love to hear more about your upcoming infrastructure monitoring and automation projects. My colleague Jared Gay has been in touch, I think, prior to the event and will follow up. Any final thoughts here, Jared?
Yeah, thank you, Ross, and thank you again for attending our webinar. I have chatted with a few of you already, but if there's any more questions, concerns that you would like to dive into with Brandon and myself, I would love to hear about your upcoming projects and upcoming infrastructure monitoring adventures.
Alrighty, thanks Jared, thanks Jeff, and thanks Brandon. We are signing off for the day. Hope you can join us on our next webinar. Thank you.
Bye, everyone.
Bye.